Let us begin with this new chapter called ellipse. So we will go through the tangents, normals, the properties, a lot of things about this particular shape called ellipse. It's how its equation is and what are the various forms. A lot of things, just the way we did for parabola and circles. So, and the things which are common to both parabola, circles, and ellipse, we'll be just rushing through them without any lots of derivation. So here, this is the first definition. It's a new thing. Ellipse as a fixed sum of distances, right? So there is obviously a way to define every conic, and that is you have a directrix, you have a focus, you have a point xy, you find the distance sp, you find the distance from here pm, sp by pm is equal to e. That's how you define it, where your e is less than 1. For ellipse, if you remember, the condition was 0 less than e less than 1. That is one definition. We'll look into that also, but we'll be starting the chapter with this different type of a definition called for ellipse. So basically, these are two fixed points called as focus, right? So here, unlike parabola, where you just had one focus, in fact, for a parabola also, it looked as if the parabola only has one focus, but in fact, the parabola has the other focus at infinity. So f1 is here, and f2 for parabola is at infinity. For ellipse, the two foci are like this. They're on the same line, and if I calculate the distance of any point on the ellipse from the first focus and I add it to the second distance on the second focus, so basically if you add the distances, then that will be equal to a fixed number, a fixed constant. That is the definition, right? So basically you can imagine it like this. If I fix two nails here, and if I tie a thread and I move the thread around, then it will move like an ellipse. This thread will move like an ellipse. And what is this 2a? This 2a will be the length of the the length of the major axis. So as you can see, a circle has all its diameters the same length, but for an ellipse, it has this major axis, which is the longer one, and the minor axis, which passes through the center. So an ellipse also has a center. We'll be looking at its center through the equations and all later. But the two axes which pass through the center, one is the major axis, one is the minor axis. So here 2a, remember sp, which is basically pf1, like the distance between the first focus plus the distance of the point from the second focus. If you add, then that will be equal to the length of the major axis. In fact, you pick up any point on this, every point will obey this relation. So if you actually carry out these calculations, so basically if you let a square minus c square equal to b square, so I'm not showing you where this is coming from, but when you actually go ahead with calculations, you will come at this expression where you'll have to replace c square. So when you replace c square with a square minus b square, you will finally be able to reduce this to this. So this is the most important form. Because throughout the chapter, we won't be dealing with this form. Maybe you might get a few questions here and there which will be based on this definition. This definition is absolutely true. Even this ellipse is obeying this definition. In fact, this form is actually derived from this form, and I'm not going to the derivation. But this form is the one which you will come across the most number of times. So this is the most important form. So with this definition done, and after calculations, when you come to this, we will now start our chapter on our discussion with this. So we will look at this form, and we'll look at every parameter based on this. So let's look at this x square by a square plus y square by b square equal to 1 form in detail.